Here's some help on assignment for homework 4.6, day 1, systems of linear inequalities. So let's do number 2. Number 1 is pretty easy. Number 2 is a little challenging because neither of your equations are in slope-intercept form. So here's what I want to encourage you to do. You could start off graphing this in the calculator first, so you can get an idea of what it's supposed to look like before you even do any math, okay? So you go to your graph screen, and I'm going to zoom out a little bit so you can see a little more. So I'm just going to type in 3x minus 2y. Now, I can't just start typing it in like this because I have f of x equals there. That's like another y equals. This is going to give me an error. So I need to go back and hit delete on my equal sign and go to relation. Then I can type in everything. So 3x minus 2y is less than 4. 3x minus 2y. And then I hit control equal sign to find my less than right here. 4. There is the graph of that inequality. Shading and everything. Okay, I hit tab. And then x plus 3y is less than 6. So x plus 3y, control equal, less than 6. I hit enter, there it is. Here's the first inequality in blue, here's the second one in this reddish or pinkish color. The solutions are found where you see the double shading, okay? I can go further than that, turn on my grid lines. If you're in the scratch pad like me, it's menu 223. If you're in a document, it's menu 263. I could pretty much piece together my lines and everything. Like, for example, this pink line is, if I go up 2, there's my y-intercept. If I go over 1, 2, 3, 4, 5, 6, there's my x-intercept. I could put the whole line together just by looking at points on the grid on the calculator screen. All right. The other one, same thing for the most part. Now, it's kind of hard to see whether the lines are solid or dotted on the calculator screen. These both look dotted. You see the little jagged edges there. But you can always see that for sure just by looking at your symbol. If there's no equal sign underneath your inequality, you know they are dashed or dotted, right? So that's a way to do that. Now that we've done it that way, though, let's go ahead and do it on paper with the math, getting y by itself. So 3x minus 2y is less than 4. I'm going to make my wall here. I need the y by itself, so I'm going to go ahead and move the 3x over with opposite math. These cannot go together. They're not like terms. I'm going to write the 3x first and the plus 4 second. Over here, this is what I have left. I need to divide both sides by this negative 2. When I divide by a negative number, I have to remember to flip my inequality. Okay? So, not right there though, right here. So when I do that, I get y. This negative 3 divided by negative 2 gives me positive 3/2. There's my x. 4 divided by negative 2 is a minus 2. That is my slope-intercept version of that. Now I want to remind you and emphasize, if I were to graph this in the calculator, it would be the exact same as this one. It's still the same thing. In fact, we can look at it. I go down 2, there's my y-intercept. I'm going up 3 over 2, up 3 over 2, up 3 over 2. There it is. Every time I'm on the line. It is the same line whether you graph it like this in the calculator or like this. That's why I'm really emphasizing that you utilize this calculator as a tool. All right? So there's that one. And I'm going to go ahead and graph it on paper real quick. Here's my minus 2. And I'm going up 3 over 2. I'll zoom in so you can see this. Up 3 over 2, up 3 over 2, etc. Now when I make my line, is it going to be solid or is it going to be dotted? This one's going to be dotted. I say dotted, dotted, dashed, same thing, right? There it is. All right, let's do the second inequality really fast. So we have x plus 3y is less than 6. Okay, again, we need y by itself, so I'm going to do minus x minus x. These are not like terms. I want to put this x first. Okay, that's just my preference. Okay, I'm dividing everything by 3. Now this looks a little strange, right? How do you divide this by 3? There's no number here. That's when you remember to write in that little invisible 1 that's there. It's really negative 1/3 x is what you have there. So y is less than, I don't flip the inequality because that 3 was not negative when I divided, negative 1/3 x plus, and then 6 divided by 3 is 2. Now take a look at my screen. That's up 2. I'm looking at the pink line. Up 2, there's the y-intercept that is right here. And it's going down 1 over 3. Here I go. Down 1 over 3, I'm on the line. Down 1 over 3, I'm on the line. So you can use this calculator as a tool even if you have trouble with all of this math on paper. All right? Let's go ahead and graph that inequality. It was up 2, y-intercept right here, down 1 over 3, down 1 over 3, etc., etc. That's another dashed line. Now let's do the shading. The shading for that first one, which I didn't do a while ago and I should have. And here's the other thing, you're using the calculator to make sure you shade it right on paper. So I'm going to do that one in yellow because I don't have pink, so I'm going to use yellow and blue. So this first one will be yellow. Everything above that line is part of that solution. The other one, right here, it's less than that, everything on that line. Sorry, not by that one, but by my final one, less than. I shade that. The double shaded area, which falls right here, that is where my solution set is. And that's how you do these. Okay, let's take a look. Maybe we'll do one more. Let's do number 6 because it's a bit of a special case. Because there's not a lot there. We have y is greater than x and y is less than or equal to negative x. Okay? So if that was a line, an equation of a line, it would be y equals x. And what is the graph of that line? Well, if I think of it in terms of y equals mx plus b, my m is 1, my b is 0. So I'm starting at the origin, and my slope is up 1, right 1, up 1, right 1. So let's go ahead and do that. All right. This is not a solid line, it's a dashed line because it doesn't have equal in the inequality. So I'm going to go ahead and do that, dashed. The inequality is greater than, so the shading is going to be above that line. So the solutions are everything above the line, not including points on the line, since it does not have the equal. That's why it's dashed. Okay, let's do the second one. Y is less than or equal to negative x. Well, if I had the line y equals negative x, it's basically y equals negative 1x plus 0. All right? So again, my y-intercept is 0. My slope is now down 1, 1 to the right each time. Down 1, 1 to the right. And so I get this kind of thing. Okay, again, actually not again. This one is a solid line because I have equal as part of my inequality. So I will be making a solid line through all these points. And this shading is below because that is a less than, makes an L. Right, my hand's making an L. The less than is an L. It's lower. The shading is lower. So use a different color and shade below that line. Let's go this angle here. And there you go. Now, the line is part of my solution, so you might even highlight the line itself just to emphasize that. Okay, on this one they ask a question. Is the origin part of the solution? Since one of the lines is dashed, any points on the dashed line are not part of that solution for the yellow. So since it's not part of that solution, it cannot be part of the solution to the system. It has to be a solution to both to be a solution in the system. All right, I hope those two examples give you some help. Before we stop, I'm going to go ahead and do it in the calculator real quick, just to remind you, even if you feel like you're doing it right, check it in the calculator. Okay, so I'm going to go to my graph. Y is by itself here, so I'm not going to go to my relation screen. I'm just going to go delete and then go to my greater than and then type in my x. Y is greater than x, and there it is. Looks just like my yellow one. There it is. Now I hit tab. This one I do have to type in everything. The y equals part goes away. So y is less than or equal to negative x, y, and then control equal, find less than or equal to negative x, and there it is. That's the exact same graph we have on the paper. All right, I'll see you in class.